everyone, welcome to this computer science module. My name is Arzamam, and today this is the second video of this computer science module. Today we'll be covering more on what exactly computer algorithms are, because in today's day and age, we've heard a lot about algorithms. Algorithms have in fact now cemented its place as a buzzword in today's hyper competitive, hyper connected world. Of course, given that we've experienced so much in this AI generation. So today, the presentation that I'll be showing you basically focuses entirely on algorithms, what they are, how they work, and why they are so important in today's digital world. It introduces algorithms as clear step-by-step procedures used to solve problems and make decisions efficiently. The presentation that I'll be covering with you today, it basically covers the common types of algorithms such as sorting, searching, brute force, and greedy approaches, showing how each of these algorithms that I've just said right now is designed to handle different kinds of problems. So to give a bit of a context, algorithms are essential because they determine how fast, accurate, and reliable a solution is, whether it's arranging data, finding information, or optimizing resources. um, Algorithms guide every operation behind the scenes. Understanding algorithms help develop logical thinking, problem solving skills, and the ability to choose the most efficient solution and the most efficient path for a given task. The knowledge is not only crucial for programming but also for understanding how real world systems like social media apps, search engines, and online platforms work, making these algorithm concepts highly relevant in our day to day lives and technology. Now we'll be moving on to bubble sort algorithms. Yeah, so these are bubble sort algorithms. Now you may ask, Orzima, what are bubble sort algorithms? Bubble sort algorithms is one of the most well-known and foundational sorting algorithms in computer science. It is widely used as an introductory example when learning about algorithms because of its clear logic and easy to follow process. Bubble sort helps learners understand how computers compare values, make decisions, and gradually transform unordered data into an organized structure. Even though it might sound simple on the surface level, it plays a crucial role in building strong algorithm thinking. So the very basic, very fundamental idea behind bubble sort is to repeatedly compare pairs of adjacent elements in a list and swap them if they are in the wrong order. So basically, the process causes larger elements to move step by step towards the end of the list, similar to how bubbles rise to the surface of water. After one complete pass through the list, the the largest element, reaches its correct position. The algorithm then continues working on the remaining elements until the entire list that you have been given is sorted. Now, this type of algorithm operates in multiple passes. During each pass, the algorithm starts from the beginning of the list and compares neighboring elements. If the order is incorrect, a swap occurs. This consistent comparison and swap pattern makes the algorithm very predictable and easy to trace. Because of this, bubble sort is often demonstrated visually using diagrams or animations, allowing learners to clearly observe how sorting happens over a specific period of time. Now, one of the strengths of bubble sort is the simplicity. The algorithm does not rely on complex logic or advanced data structures. Its implementations is quite straightforward, if you ask me, requiring only the basic loops and conditional statements. This makes this type of algorithm an excellent starting point for beginners like you who are learning how algorithms are written, executed, and tested. By studying extensively about the bubble sort, students like you can gain confidence in understanding how code controls the flow of these type of data. Now, the bubble sort is also an in-place sorting algorithm, meaning it sorts the list without requiring extra memory. All comparisons and swaps processes, it basically takes place within the original data structure. This characteristic of this type of algorithm helps us learners understand memory usage and reinforces the concept of modifying data directly. Additionally, bubble sort is a stable sorting algorithm, which means that elements with equal values maintain their original relative order. This property is important to understand in the real world scenarios where the data that you might be given may have multiple aspects and multiple attributes. Now let's move on to selection sort, as you would have guessed. So now you may ask, Arzuma, what is selection sort algorithms? Selection sort algorithms is a simple and structured sorting algorithm that is commonly taught in the introductory computer science courses like this. It helps learners understand how systematic comparison and placement can transform an unordered list into a sorted one, basically. The algorithm basically works by, by dividing the list into two parts. Number one, sorted portion and unsorted portion. Over time, the sorted portion grows as elements are placed into the correct positions. Now, the core idea, the most uh, fundamental rationale, the idea behind selection sort is to repeatedly find the smallest element from the unsorted selection of the list and move it to the very beginning of the list. At the start, the sorted portion is empty and the entire list is considered unsorted. The algorithm scans to the list to locate the smallest value, then swaps it with the first element of the list. This action places the smallest value into its correct position. The sorted selection now contains one element, and the process repeats for the remaining unsorted elements, which basically takes us to the next type of algorithm, which you would have guessed by now is insertion sort algorithms. So you may now ask, what exactly are these type of algorithms? Now let me tell you this. Insertion sort is a simple and intuitive sorting algorithm that is especially useful for understanding how ordered data can be built gradually. It is commonly introduced early in computer science education because its logic closely resembles the way humans sort items in everyday life, such as arranging playing cards in hand. The algorithm focuses on taking one element at one time and it places it into its correct position within an already sorted portion of the list. Now, the main idea behind the use of this insertion sort algorithm is to divide the list into two parts. Number one, a sorted selection. Number two, unsorted selection. At the beginning, the sorted selection only contains the first element, while the rest of the list remains unsorted. The algorithm then takes the next element from the unsorted selection and compares it with the elements in the sorted selection, shifting larger elements one position to the right to make the space for the new element. This process continues until the element is basically inserted into its correct position. Now, insertion sort algorithms, it basically works in a step-by-step manner. So during each iteration, the algorithm selects the next element and compares it backwards with the elements in the sorted portion. If the element is smaller, the algorithm continues shifting values until the correct position is found. Once these elements are placed, the sorted portion increases by just one element. This clear progression makes the algorithm highly easy to trace and understand, especially when these type of scenarios are visualized. Now, one of the key strengths of insertion sort is its simplicity. The algorithm does not require complex data structures or advanced logic. It relies on basic comparisons, shifts, and assignments, which makes it easy to implement the most in most of the programming languages such as Python, HTML, whatever. This simplicity helps learners like you and me focus on understanding how data is ordered rather than dealing with complicated code. So insertion sort it also has an in-place sorting algorithm, which means that it sorts the list without using extra memory. All the changes that occur directly within the original data structure. It basically helps characteristic. This type of trait is especially useful for teaching memory. Efficiently, and it helps students understand how algorithms can manipulate data directly. Additionally, insertion sort is a stable type of algorithm, which basically means the elements with equal values maintain their original relative order after sorting. So now another important feature, another important characteristic of this type of algorithm is its adaptability. When the list is already partially sorted, the algorithm performs fewer comparisons and shift, making it very efficient in such situations and scenarios. This makes insertion sort algorithms a practical choice for small data sets or data sets that are almost or nearly sorted basically. So its behavior in these type of scenarios basically highlights how the structure of input data can influence the algorithmic performances. So now this type of algorithm, if you may ask, is used in educational settings. Algorithm demonstrations and introductory programming courses like this. Its natural flow and predictable behavior allows you students to build confidence in algorithm tracing and debugging. By mastering insertion sort, learners gain a strong understanding of iteration, comparison, and data movement, which are absolutely essential skills in computer science. Now, this takes us to the next type of algorithm, which is an interesting one. It's the merge sort algorithm. Now, an introduction. Merge sort is a powerful and structured sorting algorithm that is widely used in computer science due to its clear logic and consistent behavior. This type of algorithm, if you ask, it is basically completely based on the divide and conquer approach, which involves breaking a problem into smaller chunks, basically into smaller sub problems, solving it, and it basically goes about solving these sub problems by solving them one at a time individually, and then it combines the results to form a complete solution. The merge sort is especially important because it introduces you learners to recursive thinking, which is a key concept in programming and algorithm design. The fundamental idea behind merge sort is to divide the list repeatedly into smaller sublists until each sublist contains only a single element. A list with one element is already considered sorted. A list once a stage is basically reached, the algorithm begins the merging process. So you may ask, what is this merging process? So basically during this merging process, pairs of sorted sublists are combined into larger sorted lists by repeatedly selecting the smallest element from the front of each sublist. This merging process, it continues until all of the sublists are combined into one complete final sorted list. So now, basically, this type of algorithm, it basically operates in a systematic and predictable manner. The division phase focuses purely on breaking the list into halves, while the merging phase focuses on sorting and combining. This clear separation of tasks makes this type of algorithm easy to analyze and understand. Each merge step maintains order, ensuring that the final result is completely sorted without a doubt. Because of this structured approach, merge sort, behaves consistently regardless of the initial arrangement, how the initial data was basically arranged. Now, which takes us to the next type of algorithm, which is the quicksort algorithm. Now you may ask, what exactly is this quicksort algorithm? So quicksort algorithm is basically a type of a highly efficient and widely used sorting algorithm that plays a major role in both the academic world, the academic study, and the real world computing systems. It is based on, again, the divide and conquer strategy, where a larger problem is broken into smaller sub problems that are easy to understand and easy to solve. Quicksort is especially valued for teaching how smart positioning and recursion can basically dramatically improve sorting performances while keeping the logic relatively elegant. The subtle idea behind the use of this quicksort algorithm is the selection of a pivot element from the list. The algorithm rearranges the list so all the elements that are smaller than the pivot are placed to the left, and all the elements larger than the pivot are basically placed towards the right. So now when this happens, this process is called partitioning. Now once the pivot is in its correct position, the list is effectively divided into two independent sublists, which can then be sorted separately using the same approach. Now this takes us to the next type of algorithm, which is the linear search algorithm. Now this is quite an interesting one, folks, because the linear search algorithm is one of the most simplest and most intuitive research searching algorithms in computer science field. It is commonly used as an introductory example to help you learners understand how computers basically locate the specific information within a vast collection of data. The algorithm basically follows, and I repeat, a very straightforward approach, which basically makes it easy to implement and easy to understand, even for beginners like you with minimal programming experience. The basic idea behind this linear search algorithm is to check each element in the list one by one until the desired value is found. The algorithm starts with the first element and compares it with the target value. If the element matches the target, the search stops and the position of the element is one it's returned. If it does not match, the algorithm moves on to the next element and repeats this type of comparison. This process basically continues until the element is basically found, or until the end of the list is basically reached. So this type of algorithm does not require the data to be sorted in any particular fixed order. This interesting characteristic, it basically makes it very highly flexible and suitable for situations where data is basically scattered and unordered or frequently changed. Because this property, linear search can be applied to a wide range of data structures, including arrays, lists, and simple collections of data. Its adaptability makes it useful in many basic application and learning scenarios. Now let's move on to the binary search algorithm. Now, this is another interesting type of algorithm because it is a highly efficient searching algorithm that is widely taught in, again, computer science because of its tremendous amount of speed and elegant logic. Unlike the linear search algorithm that we've discussed earlier in this video, binary search, it basically relies on the data being sorted, which allows it to quickly narrow down the search space and locate the target value with fewer comparison. This makes this type of algorithm an excellent example for understanding how algorithm design and structure and data structure interact to optimize performance. The fundamental idea behind the binary search algorithms as we speak is to repeatedly divide the list into two halves and determine which half basically contains the target value that we're after. The algorithm starts by comparing the target with the middle element of the sorted list. If the middle element matches the target, the search basically ends and concludes successfully. If the target is smaller than the middle element, the algorithm continues searching in the left half this time. If it is larger, the search proceeds in the right half. This process basically continues recursively and iteratively until the element is basically found or until the search interval basically becomes empty. Now, this type of algorithm basically works by systematically eliminating half of the remaining elements with each of the comparison it basically carries out. This divide and conquer approach drastically basically it reduces the number of comparisons needed compared to linear search, especially for large data sets. For example, I'll give you a practical real life scenario over here, so pay attention to this. Binary search algorithms. Okay, for example, in a list of 1024 elements, binary search requires at most just 10 comparisons, whereas linear search may require checking all of the 1024 elements in the worst case scenario. This efficiency highlights why binary search algorithm is commonly used in performance critical applications in today's real world scenarios. Now let's move on. Let's proceed with the brute force algorithm. Now, this type of algorithm is basically among the simplest and most straightforward problem solving techniques in computer science field. They basically rely on a complete and exhaustive search through all of the possible solutions to find the accurate and the valid solution. Despite of this simplicity, brute force algorithms form a foundational concept that basically helps you learners understand systematic problem solving, iteration, and logical decision making. These algorithms are often introduced in introductory courses because they clearly demonstrate how a computer can explore a solution space step by step. So, this is a great approach for beginners. The core idea behind the brute force algorithms is to try every possible combination or candidate solution until the desired result is met and achieved. For example, if one needs to find a particular number in a list, a brute force algorithm would check each number sequentially until a match is found. Similarly, in a more complex problem like password cracking, a brute force method would systematically try all of the potential possible password until the correct password is basically discovered and found. So again, these type of algorithms, as I've said before, are easy to implement because they do not require advanced data structures or optimization techniques. They are based purely on repetitive checking and basic logic. This simplicity makes them excellent learning tools for beginners. By tracing a brute force solution, students can clearly see how computers examine possibilities and make decisions based on comparison. Now we'll be looking into this fine type of algorithm for today's video, today's module. Again, now we're gonna work our way towards understanding greedy algorithms. So now you may ask, Ozma, what exactly are these greedy algorithms? Well, that's a good question because I have a good answer to it. Greedy algorithms are a class of problem-solving techniques in computer science that make locally optimal and near perfect choices at each step with the hope of finding a global optimum, like the best solution. Now, unlike brute force that approaches that try all the possibilities, greedy algorithms really focus on making the best immediate decision based on current information. This strategy is intuitive, easy to implement, and often leads to concepts. It often leads to efficient solutions, which makes it an essential concept that is worth exploring when it comes to algorithm designs in computer science education. So the main principle behind the use of these greedy algorithms is to select the best available option at each stage of trying to crack a problem without reconsidering the previous choices. This approach is based on the idea that a sequence of local optimizations will lead to an overall optimal solution. While greedy algorithms do not guarantee a perfect solution in in all the scenarios, they work remarkably well. Just remarkably well for many problems, especially those with specific properties like the greedy choice property and the optimal substructure. So now a typical greedy algorithm works in multiple steps. At each of the steps, the algorithm evaluates the current options, chooses the one that seems the best and the most optimal according to a defined criterion, and moves on forward. This decision is final and is not it is not then revised later or it is not revisited later. The simplicity of this method makes it extremely easy to implement in code and simple to trace, which is particularly useful for learners and beginners. In fact, like you who are studying algorithm thinking for the very first time. Greedy algorithms are widely applied to real world problems. So let me just give you like a list, like a number of real world applications that in which these greedy algorithms are heavily used and incorporated. Now let's take a look at the coin change problem. So basically selecting the largest denomination coins first to reach a target amount using the fewest coins possible. So this is a scenario which the implementation of greedy algorithms can most certainly tackle. Now again, our second real world application is the actively selection problem, which basically involves choosing the maximum number of non-overlapping activities from a set of scheduled events. Now for our final real life application, let's just take a look at the scenario of Hoffman coding. So basically, it involves constructing optimal prefix codes for data compression by repeatedly combining the least frequent symbols. And this is all possible, and this is all executed frequently because of the use of these greedy algorithms, which makes it extremely valuable in the field of not just algorithms but computer science overall. So now that takes us to the end of the presentation. Our team hopes that you have now got a foundation understanding of what algorithms really are, what they stand up for, and we have basically gone in depth of the type of algorithms and the real world applications. And this, in fact, is just a start. We'll be covering more than just algorithms. I'll basically hope to meet you in the next video. Thank you very much, and hope you have learned quite a lot in this 24-minute or so video. Thank you.